All right, last part to this second lesson. All right, the reason why I gave you guys this example is that I find the time like a lot of students they learn the new skill of how to turn something into a square root, and they think to themselves, all right, I gotta go and take 5.76 times itself, and then I gotta go take 75 over 13 times 75 over 13. They do all that work, and then I have to inform them that you don't have to multiply them by themselves because you're not converting them into square roots. If neither are square roots, don't turn them into square roots. Find a common language between them also. It's kind of like if two people didn't speak a new language but learned a new language. It's just a crazy metaphor. It'd be like if this person spoke English and this person spoke Italian, and they're like, okay, in order to speak with each other, let's both learn Spanish. Wouldn't it just make more sense if the Italian person learned English or the English person learned Italian? All right. Anyway, maybe that metaphor was a stretch, but the idea is, how about we just figure out, let's just take 75 over 13 and figure out what it is as a decimal. If we do that, then we can compare it to this decimal over here. I think it's a good idea. Okay? So, 75 divided by 13. So, should we guess 5 or try 6? I'm not sure. Let's go 5 just because it seems like it would be compared to 5. So 5 times 13 is 65. All right, so there's 10 here, 13. Makes sense. Subtract the 2, and you've got 10, 75.0, drop another 0. All right, 13 goes into 100. We should probably just guess and check on this. I'll guess 7. 7 times 3 is 21. Carry a 2, that'd be 7, 9. All right, so drop, it'd be 9. Drop another 0. All right. Oh, if 7 times 13 is 91, then we got to go down to 6, because otherwise it'd be 91 if it was a 7. That just doesn't work out. 6 times 13 is 78. And here's an interesting point. A lot of students will be, oh, it's 5.76. It's 5.76. And then they'll try to say that it's equal to each other. But here's the deal. This is 7.56 with an implied 0 at the tail end of it. This one I don't think has a 0 at the end of it. How many times does 13 go into 120? 0 times? I don't think so. It's actually 9 times. So 9 times 13 is, well, at this point, I don't think we even really need to figure it out. We should confirm it. It's 117. But bottom line is, make sure you guys aren't just making up stuff, like making up rules where it's like, if at some point they equal each other, then that, if at some place in the dividing they equal each other, it has to be so. No, there's a 9 there and there's a 0 there. You got to keep it going. So clearly this is bigger than that because the 9 is bigger than the 0 with everything else identical. Wow, these markers are just going. All right, so 2 lessons you learned there. Don't just randomly toss them all into the square root pile, and don't make the mistake of stopping the calculation until you get to another digit of accuracy. All right, last one, comparing a mixed number to a square root. Now, it's important to get as accurate as possible a comparison. So what I'm going to do is I'm not going to find a decimal approximation for 4 8/9. All right? I am going to get the real deal fraction and then multiply it by itself to convert it to the square root. They need to speak the same language. Let's make this one a square root. And notice I'm not putting any work in this box here. So to convert this mixed number into a fraction, because I need to multiply it by itself, I'm going to take 4 times 9, that's 36. Okay. Add the 8, it's 44. So this is 44 ninths. Converting it to a fraction requires me to multiply it by itself. Now this is the point at which I would expect you guys to show some scratch work off to the side. I'd expect you guys to say, I don't have 44 squared memorized. That would be my expectation. 4 times 4 is 16, carry a 1, 17. Drop a 0 because we're no longer using that placeholder. 4 times 4 is 16, carry the 1, 17. It's a pretty large number. We got 1,936. And then our denominator will be 9 times 9, 81. Now at this point, I need to figure out if 1,936 over 81 is either bigger than 24 or smaller than 24. So what I'm going to do is I got some extra space over here. So I'm going to ask myself, all right, what is 1,936 divided by 81? I mean, I can convert that into a mixed number, but it seems like I need to set something a little more formal up to make that happen. So 81 goes into 193 twice. All right, so I'm going over to the last digit, 193, and moving directly above that. Okay, 2 is 162. 1 times 2 is 2. 2 times 8 is 16. Subtract the 2. 1, 3, drop a 6 now. Remember, we don't drop zeros every time. If there's a digit that's still there, we drop that one. All right. So is it 81 goes into, well, 80 goes into 320, 4 times exactly. And this is more than 80, and that's less than 320. So it should be 3. So 3 times 1 is 3. 3 times 8 is 24. Ooh, that seems a bit too low. Let's do the subtraction. 6 minus 3 is 3. 31 minus 24 is 7. Nope, 7, it's good. It's good. 73 is less than 81. So this is 23 and 73 leftovers above 81. So what we did there was we made the computation that 4 8/9 is equal to exactly 23, the square root of 23 and 73 81st, which comparatively to 24 is less than. All right, so there's a lot of really rigorous calculations going on. Nothing to the point of where you're just doing long division for hours and hours on end. Now this is a lot of work, but it's the one piece of this is the work for this one problem. We're just doing number comparison. So try not to get overwhelmed. Yes, you are going to make some mistakes, but please keep checking your work so that you're not just doing it once, and then if you're doing it wrong every single time, you're not seeing where it's going wrong. Okay, that's enough for me on lesson 1.2. Get to it.